Most gun owners who destroy their firearms never see it coming. They think they're making an upgrade. They spent good money, they watched the tutorials, they followed the instructions, and then one day at the range, something goes wrong that should never go wrong. 7 modifications are doing this to American firearms right now. Not rare exotic builds, standard modifications that get recommended in forums, sold in stores, and trusted by people who simply don't know better. Number 3 is the worst one because it looks like an improvement right up until the moment it isn't. By the end of this video, you'll know exactly which modifications to avoid and why they're far more dangerous than anyone warned you. Number 7, the bolt carrier weight reduction. You've seen the advertisements, lightweight bolt carriers that promise faster cycling and reduced recoil. The companies selling these modifications show slow motion footage of their featherweight bolt carriers flying back and forth like precision instruments. What they don't show you is what happens after 5,000 rounds. Standard bolt carriers weigh between 11 and 12 ounces for a reason. That mass provides the momentum needed to strip rounds from the magazine, chamber them properly, and cycle reliably under adverse conditions. When manufacturers start shaving off material to reduce weight, they're removing the very mass that makes the system work. The first sign of trouble usually appears around the 3,000 round mark. Failure to extract becomes more frequent. Then you start seeing light primer strikes because the reduced mass bolt carrier doesn't have enough momentum to drive the firing pin with consistent force. But the real damage happens to your buffer system. Your rifle's buffer and spring were designed to absorb the energy of an 11-ounce bolt carrier slamming backward at high velocity. When you reduce that mass by 30 or 40%, the buffer system starts getting beaten to death by a lightweight projectile moving at excessive speed. Within 6 months of regular shooting, you'll need to replace your buffer spring. Within a year, the buffer tube starts showing stress cracks. The lightweight bolt carrier that was supposed to improve your rifle's performance just cost you a complete lower receiver rebuild. Number 6, adjustable gas blocks set incorrectly. Adjustable gas blocks are supposed to be precision tools that let you fine-tune your rifle's gas system for different ammunition types and shooting conditions. In the right hands, they absolutely deliver on that promise. The problem is that most people install them without understanding how gas pressure actually works in a rifle system. Here's what usually happens. A shooter installs an adjustable gas block and immediately starts adjusting it to change the recoil impulse. Setting the gas pressure too low isn't structurally dangerous, it just means the rifle will short stroke, fail to eject, and jam constantly under less than ideal conditions. But the real damage comes when shooters set the gas pressure too high. When overgassed, the bolt attempts to unlock from the barrel extension and rip the cartridge out while chamber pressures are still dangerously high. This premature unlocking creates violent timing issues that put massive, excessive stress on the bolt lugs and the extractor. A properly gassed rifle might run 100,000 rounds before showing bolt lug wear. An overgassed rifle with timing issues will show cracked bolt lugs and sheared extractors in under 10,000 rounds. The gas block adjustment that was supposed to make your rifle run smoother just turned your bolt into a consumable part. Number 5, muzzle devices without proper thread engagement. This one destroys rifles faster than almost any other modification because the damage happens in seconds, not over thousands of rounds. Every muzzle device has a minimum thread engagement requirement. For most rifle calibers, that's usually 5 full threads minimum. But threads are expensive to machine properly, and cheap muzzle devices often cut corners on thread length. The companies making these budget muzzle devices know that most shooters won't measure thread engagement. They'll install a brake or compensator that looks properly seated, but only has 2 or 3 threads actually engaging with the barrel. The first time you fire that rifle, several things happen simultaneously. The muzzle device experiences tremendous rotational force from the escaping gases. With insufficient thread engagement, that force concentrates on just 2 or 3 threads instead of being distributed across 5 or 6. Those threads immediately begin stretching and deforming. By the 10th shot, they're permanently damaged. By the 20th shot, the muzzle device starts backing off the barrel despite being, quote, tight. But here's the catastrophic part. As the muzzle device backs off, it creates a gap between the device and the barrel shoulder. Gas starts leaking through that gap at supersonic speeds, creating a cutting torch effect that literally burns away the barrel threads. Within 100 rounds, your barrel threads are completely destroyed. You can't simply remove the muzzle device and install a new one because there's nothing left for a new device to thread into. The entire barrel is scrap metal. Professional gunsmiths see this failure mode so frequently that many shops now refuse warranty work on rifles with aftermarket muzzle devices unless the customer can prove proper installation. Number 4. Trigger modifications by unqualified individuals. The trigger is the most complex mechanical system in your rifle, and it's the one component where improper modification can turn your firearm into an uncontrollable weapon. Modern triggers use precisely calculated spring tensions and contact surfaces to ensure reliable ignition while maintaining safety. When people start altering trigger components without understanding trigger geometry, they create dangerous situations that destroy both the mechanism and the rifle's reliability. The most common mistake involves reducing trigger pull weight by cutting springs or aggressively polishing contact surfaces. Shooters think a lighter trigger automatically means better accuracy. What they don't realize is that cutting springs often leads to a dead trigger where the hammer rides the bolt down but lacks the force to ignite the primer. Worse, when amateurs start filing or polishing the sear geometry, the precise contact points between the hammer and trigger, they can create deadly slam fire conditions. The hammer slips and the rifle fires when the bolt closes instead of when the trigger is pulled. This turns your semi-automatic rifle into an uncontrolled, full automatic weapon that will empty the magazine whether you want it to or not. The rifle itself suffers massive damage from slamfire events. The sudden, uncontrolled cyclic rate creates stress levels that exceed the design limits of every component in the system. Bolt lugs shear off, barrel extensions crack, and receivers can literally split apart from the excessive forces. Number 3. Using the wrong length buffers in standard receiver extensions. Here it is, the modification that 90% of builders think improves their rifle when it actually cuts the service life in half. Heavy extended buffers designed for pistol caliber carbines like 9mm builds have become incredibly popular because they smooth out recoil in those specific setups. Shooters install these longer, heavier buffers into standard AR-15 carbine tubes, thinking the extra mass will magically tame their standard rifle's recoil. The problem isn't the weight, it's the physical length. Standard receiver extensions and buffer tubes were engineered for standard length buffers. When you drop an extended PCC buffer into a standard carbine tube, you fundamentally change the geometry of the entire cycling process. The longer buffer prevents the bolt carrier group from traveling far enough rearward. Instead of the buffer bottoming out safely inside the tube, the gas key on your bolt carrier violently smashes into the lower receiver ring with every single shot. Standard lower receivers simply weren't designed to absorb that kind of punishment. The aluminum starts developing stress cracks around the 2,000 round mark. These cracks propagate rapidly because the gas key hits with a focused, destructive impact point. By 5,000 rounds, the lower receiver is completely destroyed and structurally compromised. Shooters who install these incompatible, overly long buffers thinking they're upgrading their rifle actually just turn their lower receiver into scrap metal. Number 2. Gas port enlargement without pressure testing. This modification destroys rifles by creating a cascade of failures that starts with excessive gas pressure and ends with complete system breakdown. Gas ports are precisely sized by manufacturers to provide the exact amount of gas pressure needed to cycle the bolt reliably while maintaining reasonable component stress levels. When shooters experience cycling issues, many assume the solution is simply to drill out the gas port to allow more gas flow. The logic seems sound. More gas means more pressure to cycle the bolt. More pressure means more reliable function. But gas systems don't work on a more is better principle. Excessive gas pressure creates timing issues that affect every aspect of rifle function. The bolt unlocks from the barrel extension too early, while chamber pressure is still high enough to damage brass and stress bolt lugs. The bolt carrier moves rearward at excessive velocity, hammering the buffer system and creating stress fractures throughout the receiver extension. But the most destructive effect happens at the gas port itself. Overpressurized gas flow creates a cutting effect that rapidly enlarges the gas port even further. What started as a precision-drilled hole becomes an irregular, ever-expanding crater that allows progressively more gas to escape. As the gas port continues growing, gas pressure continues increasing in a destructive feedback loop. The rifle becomes increasingly violent to shoot as the overgas system beats itself apart with every shot. Within 2,000 rounds, rifles with enlarged gas ports typically show cracked bolt lugs, damaged barrel extensions, and completely destroyed buffer systems. The simple gas port modification that was supposed to improve reliability just turned the entire rifle into scrap metal. Number 1. Barrel nut modifications for handguard compatibility. This is the modification that destroys more rifles than any other single change, and it's completely preventable with proper planning. Modern free-float handguards require specific barrel nut designs to mount properly. When shooters buy a handguard that's incompatible with their existing barrel nut, many decide to modify the nut rather than buying the correct components. The most common modification involves cutting threads or machining new shoulders into barrel nuts to accommodate different handguard mounting systems. Shooters use Dremel tools, grinders, and files to alter barrel nuts that were precision machined to exact specifications. Barrel nuts are arguably the most critical component in rifle accuracy and safety. They maintain the precise relationship between the barrel and receiver while withstanding enormous forces from chamber pressure and barrel harmonics. Any modification to a barrel nut compromises its structural integrity and its ability to maintain proper barrel alignment. Modified barrel nuts develop stress concentrations around the areas where material was removed. These stress concentrations become failure initiation points that cause the nut to crack or completely separate under normal firing loads. When a barrel nut fails, it creates an immediate out-of-battery condition where the barrel is no longer properly secured to the receiver.